Hi everybody, thank you very much for joining us today. I do apologise, this was supposed to be a live session, but the internet demons were against us and threw many roadblocks in the way. So what we're doing now is we're taking recording, so we're actually recording during the slot when the meetup was going to take place. If you've got any questions, please post them in. So either in the chat or send them to me via Twitter @LAzal or any of your favourite communication techniques. And then what we'll do, we'll try and organise maybe a follow-up Q&A or something like that. So with me today, I am very honoured to have Matt Cloyd with me, and he is going to be talking about Aspen, which is a markup language for generating graph data. Matt's got a really interesting background, so he works a lot with regards to supporting democratic decisions and transparency by looking at data and how it's being used and the connections in there. So, for example, looking at the relationships between constituents and governments and governments, and just thinking about how you do this sort of thoughtful technology type thing. So, super interesting stuff. And Matt, you're going to tell us a little bit more about your background and also how Aspen came about and what it does.
Sounds good.
Brilliant. Thank you.
Thank you. That was a great introduction. So my name is Matt, and my career so far has been primarily in civic technology. So I got my start after college teaching myself programming, kind of sourcing and education from a number of places, actually a lot of YouTube channels, before coding boot camps were really a thing. And then I started volunteering for a group called Code for Boston, which was a branch of the national nonprofit Code for America, whose mission is to use technology to improve government. And so a lot of the work that I've done at Code for Boston is to work with municipal agencies who would come to our meetups and present very difficult problems that they had, and we would attempt to really think thoroughly through those problems and build some kind of relatively lightweight but still good enough to solve the problem technology, and use that as a way to improve government and public process. After that, I worked for the Metropolitan Area Planning Council in Boston, which was mostly urban planners. I was the only web developer there, using data from our GIS department and putting together civic applications to support both our urban planners and the general public, to really democratize the data that we had and make it more accessible to the public and to people using that information to really drive public decision making and public policy. After that, I worked for a civic startup called Open Counter, which is using technology to support economic development in small and large cities and counties all across the country. So I see a real promise for technology to be used to improve the relationship between government and constituents. And after working for Open Counter, I left there to go back to grad school full time to get a master's degree in conflict resolution. And in one of the classes there, we were modeling a conflict, so paying attention to kind of digging into all of the factors and how they relate to other factors. And as we were drawing out all of this on a whiteboard, I realized, oh, this is just a graph. And I had just started working with Neo4j like weeks before that. And so I looked at this whiteboard of this fairly complex conflict and all of these interrelating factors. And I was thinking, wow, it'd be great if we could put this into a graph database and see like a big picture, the whole landscape of the conflict, everything that's going on, how it relates to other things. And then might there be a way that we can, once we get it in the database, use a graph algorithm to say, this factor over here could be solved if we use this resource over here. Is there a way that we can get it there? And so what I started doing was trying to just like write a cipher statement to pop the data from that whiteboard session into Neo4j. But I quickly ran into some roadblocks and frustrations. I was trying to write it all as one cipher statement, and I was finding that you really have to pay attention to the order that things appear, and you have to have nicknames for nodes that are going to be used multiple times. It was a lot of data management when all I wanted to do was write a simple description of what the conflict is, what the factors are going on, and see a graph of it. And And I know there are ways to, import data through spreadsheets and other things, but I was really wanting to just like write notes and not have to pre-structure all of the data. And I came up with the idea for a markup language to do something like that. And so over the past 6 months or so, I created a markup language called Aspen, which I like to think of as sort of like Markdown, but instead of generating HTML, you get graph data out of it. Oh, sorry, just gestured my headphones out of my ears.
No problem. But that's super, super interesting, because I think we were speaking a little bit earlier about, and it's really fascinating when you talk about dispute resolution, because you wouldn't normally think about it, but if you start unraveling it and unpacking it, and you sort of think, well, actually, there's a lot of dependencies and interdependencies going on there. So somebody wants resource A, but for resource A, somebody else wants resource B, and then resource B is kind of connected to resource C. It's so you, as you say, like when you start drawing it up and you start connecting lines to it, you go, this seems like a really sensible thing to be able to in some way bring that data in and query it in a sensible way. But absolutely, as you're describing, when you're thinking about you digging this information up, it's not going to be in a nice handy spreadsheet which or triples or anything like that. You've probably got sort of paragraphs of text or something like that, and you can easily see when you're talking to people and you're collating that information, it's not going to lend itself into an obvious format that you would just go, right, perfect, let's import that and go. So no, it's super excited to see sort of Aspen as a markup language and how all of that works and how it has that. And probably worth mentioning as well, so for those of you who are watching this either before Nose 2020 or the day of Node, so Nose 2020 is on October the 20th, Matt is talking, he's got a session. For those of you who are watching this afterwards, you can watch the recording of the session. So I'll make sure we've got all of the relevant links in the YouTube description, so keep an eye out for that.
Yeah, thanks for that.
No, absolutely, no. There's super exciting stuff. So sorry for interrupting, but
no, thank you. Yeah, you bring up a good point, which is like the idea for Aspen was to let people, especially, I do see a use case for this eventually with fairly non-technical users, to just write out notes of what's going on and have paragraphs of text and just add a little bit of markup and then really be able to see a rich graph. And this feels like a good segue to just pop over to the Aspen editor and get into some live code examples. So I'm just gonna do the screen share thing here. And let's see, is that coming through clear?
Oh, perfect.
Great. So what I have up here is the Aspen editor. It's just a playground to try out Aspen. If you want to use it, it's try.aspen-lang.org. And essentially what happens is you type Aspen on the left and get a graph on the right. And I've preset this up. This is not proper Aspen, but what we'll do is we'll take this text and walk through how to convert it from just plain text to Aspen that will produce a graph that looks like this. Couple notes before we get started. So I'm fairly new to JavaScript and React programming. The fact that this editor exists at all is a miracle to me. But you'll see that the tooltips are appearing in kind of a weird spot over to the left. So that's not you. That's on me. And yeah, so also all of my example code is from the TV show 30 Rock. So all the references are to that, but you don't need to understand that to follow along with what's going on here. So you can see here, we just have a simple set of text. We've got a simple relationship here. Liz knows Jack. It's person to person. Liz works for Cabletown, so person relating to a company. And then Liz supervises, and there's a list of writers who are or have been part of her writer's room for the TV show. So you've got Frank, Lutz, and so on. So what we'll do is we'll just start with this first statement. I'll clear some of this out of here. So Aspen was designed to be a shorthand for Cypher originally. And now, as you can see here, has some other adapters, JSON, Cypher, and GEXF. So it's slowly becoming, or not slowly becoming, it's already become somewhat graph format agnostic. So because it was designed with Cypher in mind, it retains a lot of the Cypher conventions. So in order to turn this simple statement, Liz knows Jack, into proper Aspen, we just surround the nodes with parentheses, and we surround the relationship with square brackets. And you can either click Convert Aspen, or you can use Command Enter as the keystroke to refresh the graph. And here we have the graph representation, Liz knows Jack. And if we look at this, we can see that the type, or in Neo4j, the label is entity. That's just the system default. And there's nothing special going on here. It's just the content that's assigned, that's in the parentheses here, just gets assigned to the attribute name also by default. And there are a couple ways to change these. So right now, Liz and Jack are unlabeled nodes. They're just pure content. If we wanted to make them both person nodes, we would type person and then followed by a colon, or person followed by a comma. You can use whichever format you like. And when we refresh the graph and hover over, we can see that both Liz and Jack are person type nodes. You might also be thinking, if I have to type person before every single person and my data set is all people, that's going to be really annoying. And so we have a way to configure Aspen to kind of know or assume what's going on. So if you write, basically it's a YAML syntax above 4 dashes, is the configuration section, or what I call the discourse, because discourse is a way of speaking about a subject. So this up here will be the discourse. Down here is the narrative. It's the story of the data. So if I want the default label to always be person for any unlabeled node, I just say default label. It's going to be person. We refresh the graph, and we can see that Liz and Jack are both person nodes. Similarly, if we want to change the attribute that the content gets assigned to, we just say default attribute is first name, refresh the graph, and we've got first name as the attributes here. And there's a little bug in the tooltip, so I'm just going to refresh the page here.
So what would happen if you've specified a default label and you then decide you're going to put, I don't know, for Liz, actor, comma, Liz? Would that give it 2 labels, or does it overwrite it and say you're a actor node now?
It would only give it 1.
Okay.
Yeah, so this is just for an unlabeled node. The defaults is if you have an unlabeled node, it would give it person. And then if it's labeled, it uses the label.
No, but that's super, super useful in the sense of you could be, let's say you're dealing with, I don't know, let's pick stakeholder for argument's sake, because we're talking about dispute resolution earlier.
Right.
So you may not necessarily know to begin with what actor that stakeholder is. So you, by default, everybody's an actor, and then maybe as you're doing the interview, you get a bit more information. Oh, so that person over there is I'm now flummoxed as to what I would pick as a a homeowner
Sure.
or something like that. So then you're almost using it like sort of default attributes for everything, or default label, and then it just runs it. So no, that's really, really nice, because that'll save a lot of typing.
Yeah, that's the idea. And Aspen is designed to be sort of a subset of Cypher, so you can't really do multiple labels on a single node. It's not currently set up for that, but hopefully this covers a lot of use cases and could be used as a rapid iteration tool before creating your proper production level schema.
Oh, absolutely. And for the purposes of writing things out, because it's not always obvious when you're, certainly from a data modeling perspective, it's not always obvious that you may have more than one label, or the reason why you're using more than one label may be for a performance situation, or but not reflective of the current situation that you are looking to describe. But no, that is really, really cool.
Yeah. So let's see. The other thing that comes to mind for this example is you can see here we've got Liz knows Jack, and you've got a clear arrow there. It's a one-directional relationship. And for something like knows or like is friends with or something, there's usually a reciprocal nature to that relationship. So if we wanted to say that a certain relationship is reciprocal, we just say reciprocal. And then we list out the relationships in here that we want to be reciprocal. So now we see here, there's no arrow on either side. It's an undirected or mutual relationship.
Very cool.
The next sentence we had earlier was Liz works for Cabletown. So we'll go ahead and surround the nodes with parentheses and the relationship with brackets, and we'll rerun the graph. And what's going to happen here is because we don't have a label, the default label assigned to Cabletown, which is a company, is going to be a person. And you can see that here. It's set as a person. So what we can do instead is just say company Cabletown, and there we go. It's a company.
That's really
and
cool.
Eventually, I want this to look a little bit more like the native Neo4j Graph Explorer, where like every node type has a different style. It's just not something I've gotten around to yet.
No, and I really like as well. So obviously you've got sort of your aliases for your nodes, and obviously it's just going to pick it up. And I like that how it just auto connects. I mean, it's just those little things, but you can see how that quickly builds up that story. And I mean, straight away I can see how this would be really powerful if you were trying to do a graph model or something on the fly based on input that you're getting from people. That is like really, really nice.
Yeah, and I'm going to do one more little piece of Aspen here and then show the cipher that's happening behind the scenes, because it's pretty wild what 3 simple statements can generate. So let's do the last statement here, which is a list. So instead of copying and pasting, like Liz supervises Frank, and then copying this for everybody to get all these simple relationships, Aspen also supports a list form. So to get that going, so we have a simple list here. We would just surround the subject in parentheses, the relationship in brackets. And then what we can do here is this third piece it's an optional label. We don't need this. We can just end with supervises. But let's say we have a list and we want it to be a specific node type. We can say Liz supervises writers, Frank lets James Twofer Spurlock, Sue, and Abby Flynn. And in the show, Abby Flynn isn't really a writer so much as she's like a comedian that they hire. So we're going to just label her as a comedian. And if we run this, what you can see here is, so Liz supervises Frank. And you can see that we said writers because that's more natural in the language here. Liz supervises writers, but what we're getting is a singularized version. It's assigning the label writer. And if we go over to Abby Flynn, we can see that the comedian label overrides the list level label. So she's listed as a comedian there. And if we were to, sorry, go ahead.
I know, just saying that's really, really cool.
Oh, cool. Yeah, thank you. If we were to remove this label too, what happens is because there's no label and we just have content here, it's going to use the default label. So everybody is going to be labeled a person, except that overriding last label is still going to apply. So Abby is still listed as a comedian. And down here, so what's happening behind the scenes for the Aspen editor is this is actually converting into a JSON graph format and being visualized by a library called G6. And that's what's going on here, but you can copy either the JSON data, cipher data, or GEXF data. And I'm just going to copy the cipher data and pop it into open text editor window over here. This is the cipher that's generated from this Aspen. So you can see here, you've just got a few simple statements with a little bit of markup and a list. And this is the cipher that you would need to write and kind of keep track of in order to generate the same amount of data, just handwritten.
No, that's really, really nice. And yeah, you could easily, I mean, certainly I could easily see like a huge number of use cases for this. So anything from you want to pull some sample data together, like you're pulling together a story and you don't quite understand, or you're working with, a lot of stakeholders and they're trying to describe what's happening or things interacting, and just being able to capture all of that. And this is very user friendly. So, I mean, you can always do the decorating of the default and the things later, but the fact that you can sit down with a number of stakeholders and just say, okay, so you're saying Liz knows Jack, okay, we can write that down. If you're not too sure about the relationship types, you can keep jotting them in. The fact that you can do the list, and it's human readable, and it's such a small amount of annotation that you need to do to then give it enough to then sort of further process that. And I mean, straight away I'm sitting here thinking this is a great way to be able to capture information and then generate a graph data model. So effectively pull common themes and get a schema out of it. Or the fact that, again, you can map a supply chain very quickly, where perhaps it's not obvious to begin with. You're working with business analysts or something, and you're getting the information from them. Again, it's not going to come as a model. So no, this is really powerful, really, really powerful.
This is making me feel really good, because I've been mostly working on this like in isolation. So getting any kind of feedback feels great. So, thank you.
No, thank you. This is an amazing contribution. This is super cool. So,
So we're still like in the basics too.
There's more.
Yeah, there's more. If we want to get a little more complicated. I'll just show two more kind of basic things. So let's say for the company, right now the system-wide default is that whatever content is in the node besides the label is the name, but we can change this per label type. So what we can say is we can set default attributes. Before we did default attributes, which was just one piece of content. But we can start listing out here the attribute names that we want. So let's say we want Cabletown to show up in our schema as the legal name, and for comedian, we actually want this to be an alias. If we were to rerun this graph and go to Cabletown, we can see it's been assigned legal name Cabletown, and for Abby Flynn as a comedian, it's an alias instead of name.
Oh wow, that is really neat.
And the one last piece that I want to cover with the with kind of the basic, or what I call vanilla Aspen, is a little bit of protections or guardrails. So let's say we're typing and we've got a lot of content, and we want to make sure that our labels are all consistent, and we've got we're not making typos in our labels or typos in our relationships, because that'll make it harder to query later. What we can do is we can say allow only, and then list nodes and edges that are the only ones that are allowed to be in this schema. So for example, in this one, we've got person, we've got company, and we've got comedian. And actually, let's say we only want person and company to be in this schema. What we can do is say, allow only nodes, person and company, just comma separated list. And we get an error that says your narrative includes a node with the label comedian down here, but only person and company are allowed. So we have to either add comedian up here to allow it, or delete this label here. And the same thing is true of edges. And you can use either a comma separated list or a YAML style like bulleted list. So we can say nose and works for, nope, I'm doing the YAML style list here. And we've also got an edge called supervises. So let's go ahead and add that one in as well. And now if we make a typo, it won't let us, it'll warn us that something's going on here, so we can check ourselves.
That's really smart. I like that. That is really, really smart. Can you also do that with properties as well, or attributes, or is that coming soon?
Ooh, that's a good idea. Not something that I had thought of, but to be added.
That is really, really nice, and I like this idea of you're putting in the guardrails, as you said, so that you don't put this huge amount of this effort in, and then you discover that you've introduced 27 new relationship types on your way down of this 5-page essay. So
yeah, I think I probably did an example where I had a bunch of different relationship types and it was like, why am I not getting any data out of this query? And it was typos, obviously. So that's the basics. Do you want to dig into the really cool stuff?
Sorry?
So one of the things that came up while doing this is I realized that the only thing that you can model easily in Aspen is kind of A relates to B. And I wanted there to be a way to have much more complex relationships and still use a plain text description in the narrative. And so I introduced a feature called custom grammars that we'll just walk through right now. So let's say we have this data here. This is kind of coming from the example in my nodes talk, not quite the same example, but this sort of simplifies it for this kind of demo. And technically we could do the vanilla Aspen thing here and just do this. But what I want to do is show custom grammars using a pretty simple example. So this is a little bit convoluted, but should be fine for demo purposes. Another thing to note is that custom grammars are only available in Cypher. It's tricky to get JSON and GEXF to encode this right. I am going to be working on that. So custom grammars are only going to work if you're exporting to Cypher. So what's going to happen while we're doing this is it's not going to appear in the graph the same way. We'll copy the Cypher and pop the resulting data into Neo4j to visualize it. So this is kind of a growing edge of the language. So I'm going to cut out some of this stuff here and just say, okay. So in this example, we want to use a custom grammar to encode these sentences, and we're not going to use any markup on it at all. What we're going to do is define kind of a matching pattern, and the matching pattern is going to match each of these sentences and create Cypher to encode the relationships the way we want to encode them. So for the first grammar, we'll just say match, and we provide a list of sentences that we want to, or patterns that we want to match. So we have, just for this example, we've got is a and is an. So I'm going to just start by copying and pasting both of these sentences in. And if you're a little bit lost, it's okay. Hopefully it clears up in about a minute. So what we want to do is we want to assign Jan and Michael and Ari to be person nodes. So we're going to just replace this with person. So we start each I call this a match segment. So each match segment is made up of a type, and it can be a label for node type. So we'll say person, and then we assign it to a variable. So we're going to say P here. And city councilor, advocate for small businesses, we'll call this a position. And that's going to be a variable pause. So we'll do the same thing here. And so what's going to happen is the custom grammar is going to come through and see all three of these sentences and match it using one of these matchers here. So Jan will be assigned to the person node, city councilor will be assigned to the position node. And it'll be available with these variable names, P and pause. They can be anything that we want to be. And then we'll provide a template to provide the cipher that we want to result anytime we match a plain text sentence like this. So we want to say P is pause, position. And we'll just surround these with triple brackets. I can kind of go into that in more detail about why that's the case later on. But this is essentially what we want to do. So we're capturing Jan to person P, it's being assigned here, and then it's used here in Cypher to create this statement. And this like little vertical is YAML shorthand for a multi-line statement. So if we had other things we wanted to add to the Cypher statement, we could just add them down here. We don't need any of the merge keyword. That's all taken care of us in the when Aspen compiles. So I'm going to run this now, and I don't think we're going to really see much of a graph. Did not find expected key. There we go. I just indented a little bit too much. So we can see there's some like weird stuff going on with the nodes here, and that's because the JSON adapter doesn't know how to handle the Cypher statement. So we're just going to copy the Cypher and look at it over here. And you can see what's happened is we have all of the people, Jan, Ari, and Michael, and all of the positions, city councilor, transportation activist, advocate for small businesses. And it's created the relationships down here using the Cypher that we defined here. I know that's kind of a lot. Does that all generally make sense?
Oh, that's brilliant. I love it. So effectively you are giving, like say you've got template, you're effectively creating a template and a pattern. And I'm sitting here thinking this is marvelous, because you think if you've got a fairly, I'm just trying to think examples, because there'll be certain examples of documents where you don't tend to, you're not going to have a very rich vocabulary describing the relationship between two entities. It's probably going to be is an, that kind of thing. And I'm just sitting here thinking you almost are at that stage, or maybe that's. I'll ask you about next steps for Aspen, but
Sure.
you're kind of thinking you're not that far away from being in a position where you could build out a template and how you want those things to be represented and what is the situation, and being able to just copy paste big chunks of text out of an official document and just know it's going to go into a graph. And this is really, really cool. And again, you can just sit there and see all these amazing opportunities that are presented from this. This is really, really cool.
You kind of touched on what I do in my nodes talk, and I can actually just give a quick preview of that. So the template there is much more complex, and let me just pull that up. I've got it copy pasted
spoilers
here. So I'll explain this. It's a little bit much, but what I do in my talk is I take comments that come out of a Co-Urbanize instance. So Co-Urbanize is a startup. I believe they're Boston-based. I knew a few of the developers back in the day, and it's a way to give feedback and have an online public process around certain developments. So Kendall Square has been undergoing some redevelopment. This is in Cambridge, Massachusetts, and these are all comments from folks. And what we've done is essentially rewritten them using a framework or a formula that comes out of a certain school of communication called nonviolent communication, where we have we separate an observation, a feeling about that observation, a want or need, and a request. And it's just a way to help people understand each other a little bit more clearly. And what's going on is, the basic idea is a person observes an observation, feels a feeling, needs a need, and requests a request. This isn't a very good graph model because if you add a second experience, you can't really clearly query, is this observation related to this feeling or to this one, unless you do some convoluted stuff with identifiers, but I don't want to do that. And so the graph model that came out of a little bit more thought was a person has an experience, and that experience has these constituent components. And that way, somebody can have multiple experiences, observing two different things, feeling two different things about it, needing two different things, and requesting two different things, or more than two. The tricky part here in Aspen is how do we create this experience node? Because it's relatively anonymous. There's no content that goes into experience. It's just kind of an empty node that is there for structure. So what we do, I added a special tag. Anytime you have unique and UNIQ, it's the spelling that's taken from Ruby, underscore, and then any kind of text, what happens is it creates a unique identifier for each sentence. So this one will be unique, it will be experience or EXP1, this will be EXP2, this will be EXP3. And so what we're doing is we're saying, so we've got this matcher where person P observes observation OBS and so on and so forth. And we're using P here, the person node has experience, and then we create the experience node using Cypher. And we use this tag to set up the nickname. So the first experience will have unique experience, so it'll be EXP1, and then the ID will be the string EXP1. And that kind of creates that experience node that we can refer to by the nickname later and just assign it the experience. It gets assigned the observation, the feeling, the need, and the request. So if we were to convert this Aspen and copy the Cypher out and take a look at what's going on here, you can see I'll put the template and this one block here side by side is we've got this first person, Harry. Nope, I won't go back and forth between those. So Harry has an experience, and you see here EXP1, and that's coming from that, and then EXP1 is all here. So you can see how those two map together.
No, that's really nice. I like that, and I like this idea of yes, if you can get the standardized language, because I was thinking as well, is there something around as well doing something your various NLP processes that you have to try and do things like it's useful obviously in many situations where it's really useful to have that verb so you understand what kind of relationship there are by two nodes. Imagine where can you use the opportunity as well where you can sort of strip out and just find the two objects that are related, then you combine them with the templates, and then so many exciting things. I'm just thinking of all these exciting projects I want to try out now. This is so cool.
Yeah.
so cool.
Be happy to support those projects. I'm really excited to see how Aspen is going to be used. And just so you see, this is the Cypher. I pasted the Cypher into an empty database, and this is the model that comes out of that. Just this matcher up here, which admittedly is a little bit complex, but once you get the hang of it, it's pretty natural to create. And so these three sentences here have created this graph.
Yeah, and immediately you can start to see how you've got a simplified interface where you can start pulling in, lots of these kinds of statements, and then you can start seeing, do you have more than one person who's, required a raised crosswalk, for example, which you've got here with Harry and Ari as an example, and things like that, and it just starts to become like really interesting, and it's a really neat way of being able to bring in statements and very rapidly do some kind of analysis on what's happening, what's the state of play, what's the current situation, that kind of thing. So that is really nice. So I do have a question. So you mentioned about the triple curly braces. So I'm going to raise that. So what's the story behind those?
So as part of this language, I'm calling in two other languages. The first you can see is YAML. We've got that YAML structure here. And the second language that comes up is Mustache. And Mustache is a very simple templating language. Typically, you use two braces around an identifier, and it replaces it with the string or the number or what have you. And you can do that. There are string types and number types built into Aspen. But in order to properly render like a very rich node, you have to use three braces. Otherwise, it does this like weird escaping thing. So let's just do it on the person here. I don't even know if this is going to work. I haven't tried this in like a month. But what is going to happen is... Did that work? Oh, interesting. Maybe there actually isn't a problem anymore. At one point during development, it was escaping the object. So there were a lot of like weird backslashes and other things that messed up the cipher. So 3 has been safer, but now that I'm seeing this, I don't know, it's possible that 2 will work fine.
It's cool. And I do have another question as well, quickly, because I appreciate we're coming to the end of the session. What's next? What's the plan for Aspen? What are you sort of thinking about, sort of implementing or doing, or what's the thinking?
Yeah, so the first thing that comes to mind is, so this has just been a personal project of mine. This is something that I really wanted to see and really wanted to use. So I've just been working on it solo. I've got it to this point, feel pretty good about it. And I am a Rubyist by trade so far. And I know that Ruby and typical Neo4j stacks, it's a little bit of a mismatch. And so I built the Aspen editor playground to let people try it out. But you do have to have a Ruby environment installed in order to use Aspen kind of on your local machine. There are some really great tools that come with the command line interface, like it can watch a folder of files and automatically convert anything you type in Aspen to Cypher and push it to a Neo4j database. So there is some value in kind of that native CLI. But because it's been a personal project and it's not really sponsored, it's kind of stuck in the Ruby ecosystem. So if you're watching this and you're thinking like, hey, I really want to use this, if there's something that you can provide, either developer support or sponsorship for a specific scope of work to port this to a different ecosystem that maybe lines up with the better lines up with the typical Neo4j stack, that's definitely a place that I want to take this language.
Fantastic. No, that's really, really cool. And again, so the call to community, if this is something you can join in with, please do. So it's probably worth mentioning at the top, we've had the address the full time. So you've got a handy link to get the contact details for Matt. And I believe on there you'll have the details for Aspen, get in contact with yourself and that kind of thing. So yes, so the details are up there. Please do check that out. But yes, so thank you very much. That has been absolutely fascinating. I've really enjoyed that. This is a really, really exciting tool, and I mean, I speak for myself. I'm sure everybody watching this will be the same. I'm sitting there going, there are so many cool applications for this, and really, really excited to see where this goes. And let's chat about what other cool things we can have a play with this.
I love this. It sounds great. It's so validating to hear this, because I've been using this as like a thing that I know I want, but I haven't really put it out there before today, like a little bit at Graphs for Good, but it's really, I'm really, really grateful to like hear that reflected of like, this is something that that could be really useful. So I'm excited to kind of continue bringing it and taking it where it needs to go, and hopefully it helps a lot.
Brilliant. No, thank you so much.
Thank you.
Again, for everybody who's watching, so I appreciate this is a recorded video, so if you've got any questions for Matt, again, either post them as comments on the video or reach out to me, and we'll organise something to get those answered. So yes, thank you once again, Matt, for joining me today. It's been absolutely brilliant, just fantastic seeing it.